When you partner with Axon, you immediately gain access to a full range of products and solutions designed to meet the complex needs of today's grower. We carry all major brands and sizes of tires and wheels. We specialize in large diameter wheels for large equipment. We have one of the largest OEM replacement wheel inventories in North America. Known for extreme flotation setups, duals, and triples, we have wheels for all makes and models of tractors, sprayers, combines, and grain carts. If we don't have the wheel in stock, we'll custom build, sandblast, and paint in-house. There isn't a more vast inventory in North America dedicated to helping dealers move more iron. With facilities on the West Coast and in the heart of the Midwest, leverage our 230,000 square feet of indoor inventory to solve any problem a grower may have. Move more iron with Axon.
Moving iron.
Hello and welcome to Moving Iron Podcast. Marcus with Shawn Hackett. Shawn Hackett is with Hackett Financial out of Boca Raton, Florida, and he's nice enough to come on and talk about what's happening in the marketplace. Shawn, how you doing this morning?
I'm good. Finally getting over a cold here, but I'm coming out of it, ready for some tryptophan here on Thursday.
Yeah,
and getting ready for some nice relaxing time with family, as I'm sure you and everyone else is. So.
Yep, it's a Thanksgiving's one of my favorite holidays. You know, there's no expectations, pretty easy. You just eat and watch football. I don't know how much more you could ask for in a holiday, but that's a good one, and you get to.
I make sure that when everybody comes over that I have a bunch of dull knives. Everything's been working out ever since I've done that.
That's good. That's a good idea. Take the shivs and put them away for the holiday.
So even if accidentally things are being thrown, the outcome won't be too bad.
Yeah, it's it always comes out in the wash, right, Shawn? Yeah. All right. So I felt like we need to talk about this because we've talked about it before on the show. I have had this is probably the second or third article that I've seen pop up in my news feed about this, where they've asked a question about volcanic activity. And if you look at the Smithsonian Institute's volcanic program, they say that the average number of volcanic activity of volcanoes going off at any time should be somewhere between 40 and 50 volcanoes at any given time. We are within that 40 or 50 volcanic activity going off at this time right now. I think we're at 46 right now, so we're on the high side. But what I think is interesting about the topic is that not so much the number of volcanoes that are going off, but the concentrated fact of where those volcanoes are going off at. So we've talked about on here a few times as the grand solar minimums take place and the sun's activity weakens and less cosmic rays are hitting the sun's magnetosphere or the Earth's magnetosphere, the amount of it weakens that magnetosphere, which then does tend to cause tectonic plates to have more freedom to move around. And we've talked about this before, that some of the biggest volcanoes that have gone off during a grand solar minimum. What's the one with the summer with the year without a summer?
Mount Tamboura,
Mount Tamboura.
1815, I think it was.
Yeah.
Was VEI 7. It was just unbelievable, and it did create not only the year without a summer here, but the year without a summer everywhere. I mean, it was crop failure, famine time for the next couple of years because of that. They call it the nuclear winter, as a terminology, because it was just brutal. Yep. Of course, that occurred when we were at the peak of the low sunspot cycle, so the planet was already cooling, and then so that just added the final catalyst. And actually, the lowest temperatures Earth has seen was those 2 years, and then we've been warming up, ever since we came out of that. Yep. So that was actually your low temperature. Earth temperature was right in that 1815, 1816, 1817, up to this point. And so what we're looking ahead at now is a trough of this solar cycle in the late 2030s the early 2040s. So we would anticipate that because of that, and because the sea surface temperature cycle is expected to turn down post 2025, meaning that the Atlantic Ocean is going to go into the cold phase and couple up with the cold Pacific Ocean, both of those cycles will be in the cold mode at the same time, which hasn't happened really since the Maunder minimum was the last time we had those two cycles going together at the same time. And as you know, one of the triggers that we're watching for the Atlantic Ocean to go cold is the Beaufort-Geyre reversion of the clockwise flow to the counterclockwise flow that the Oceanographic Institute of Woods Hole, their latest paper from a few months back, says their title was an imminent reversal of the Beaufort-Geyre. And so that's kind of, and then so with those two cycles in place, we then would be, if we were to get one of these VEI 6, VEI 7 during this 10 to 15 year period, we would be looking at something most likely like that, where we'd be making that we'd have that kind of reaction in the atmosphere and reaction to temperature. So, I don't say any of that because I'm excited about the prospects of all of that, but this has happened before, many, many times before. And unless the natural forces of nature and the sun and Earth and the planets and all the magnetic fields and gravimetric strengths that are involved have changed, which I don't believe they have, then that's what we're looking at. And we need to prepare, act, adjust, and be aware. No, you can't avoid every risk that's out there in life, but you can mitigate some. And I always tell everyone, always, because we live in Hurricaneville down here, that even if a category 5 or 6 is about to come over Boca Raton, where I live, no, I can't alter all the risks that's going to happen, but I can mitigate them to the point where there's a pathway forward. Whereas if I don't know it's coming, like in the 1930s when they did not know it was coming, then it's catastrophic loss of life. And that's what you want to avoid. Property is going to be damaged, but you just want to avoid loss of life. So,
okay. So the volcanic eruption index, right? VEI. Right?
Volcanic explosivity index.
Okay. All right. Yeah. Explosivity index. That is, I'm sure that's a exponential thing, right? So the difference between a 4 and a 5 is 100 times or 10 times.
It's like the Richter scale. If you look at it, it's an exponential. It's an exponential increase in strength.
Okay. All right. So go ahead.
Go ahead. I
was going to say, so so you say you had one VEI 6 go off, and then say you had 5 VEI 4s go off at the same time. How does that, is it the difference between where it reaches in the stratosphere, how that reaches then stratosphere, how that affects what goes on as far as blocking out the sun rays, or is it the volume? I mean, what is it that we're looking for here of ash?
The first thing is the column height has to reach 30 kilometers in order to sufficiently be in the middle part of the stratosphere. So first of all, whatever the plume, the column of plume, has to be strong enough to get up to that high. So Tonga was got into the mesosphere. Only one other volcano has ever gotten to the mesosphere, which is the outer atmosphere. So that column height was incredible. Now, the reason why that wasn't a VEI 7 is because the material that it deposited in the stratosphere wasn't enough to equate that. Meaning, there's a definition for it. Okay, and so it's not just column height, but it's actual amount of aerosols that are deposited in the stratosphere. So there's the eruption. Now, does the eruption last 1 hour? Does it last 3 days? That has a lot to do with how much aerosols get deposited in the atmosphere. So the first thing, I have an equation that I found from a hotshot scientist from 100 years ago that I'm able to determine whether a volcano was a VEI 567 within 1 day of the eruption by looking at column height and uh, aerosol material. And it's been back tested 1,000 years to be, with a 92% correlation coefficient to the actual determination of the volcano many, many months later. So I can pretty quickly figure out whether something's a VEI 567 within 24 hours of the eruption. So that's what we're looking for. Height, is it high enough? And long enough, is it putting enough of that sulfur dioxide, or in the case of Tonga, water vapor in the atmosphere to equate to a 6, a 7, or an 8? Just to give an example, I think in Earth's history, I think there's only been 3 or 4 8s. I mean, that's like extinction of the human race kind of stuff.
Right.
So we'll put that aside.
That's like a Yellowstone super caldera.
Yeah, I mean, that's kind of like,
right.
We're going to start over.
Right.
We're just going to start over.
Yeah.
Some new cells are going to start developing in some petri dish in some ocean somewhere, and we're going to start from scratch because when that happened to the dinosaurs, I don't know, but we're going to start from scratch. That's a VI. That happens. It's we're all going to see the light at the same time, hopefully.
That's right.
So
yeah.
We'll put that one aside. But VI 6 and 7s, we get them. Obviously, 7 is rough. Like I said, the last one we had was Tamboura, but more likely we're looking at the 6s, like Tonga was. So that's how that's what it is. And then the idea behind it, if you have a volcanic eruption that's high enough but doesn't put enough sulfur dioxide in the stratosphere, that means you're not going to get the disruption in the upper airflow pattern. You're not going to get the cooling effect. It's not enough to create a major global weather impact. You need both the height and the quantity, because once they get up there, they'll stay up there. Those aerosols will stay up there for 3 years before they dissipate, at least for sulfur dioxide's case. For water vapor, it looks like it could be 4 years versus 3. But if it's not enough, then it just disperses because we have this big stratosphere, and it has only minor impacts, mostly locally. So that's what we're looking for. Not that I'm looking for, but that's what you want to need to be on the mindful of. Height 30 kilometers or more, and quantity of material. There are websites that I have found that measure real-time sulfur dioxide emissions in the stratosphere. So, like, there's a volcano going off in Papua New Guinea, not a major one, by the way, but you can see how much sulfur dioxide is being emitted. It's not going in the stratosphere because it's not tall enough, but we have a way of saying how much is going up there within real time. We can see how much is being emitted and is it going high enough. So, luckily, fortunately for us in this day and age, we can know exactly what's going on. Whereas 100 years ago, 200 years ago, nobody had a clue. It was just, we had no idea what was going on. So that's what we're looking for, because sulfur dioxide, remember, if you look at sulfur dioxide, it causes these mirror-like spheres in the atmosphere, in the stratosphere.
Right.
They act like mirrors, and the sun gets blocked away. Sun gets blocked away. Sun gets blocked away. So not only do we have a weak solar output, but then whatever is trying to come in is getting blocked out more readily. And then it allows heat to escape, causing a massive cooling effect, and air sinks on Earth. So you get rapid sinking of air. And when you get rapid sinking of air, you get wild weather volatility off the rails, and obviously very difficult growing conditions. So that's kind of what we think that scenario is going to show itself. And when it does, I think everyone needs to realize that, at least for agriculture, prices are going to do something materially different when and if that scenario takes place than it's ever done before in modern day times. So,
right. So that's why I thought these articles were so. I mean, you see two or three articles pop up on something like this, and they keep fanning the not even fanning, trying to throw a wet blanket over what's going on around you, basically saying, hey, you know what, nothing to see here, nothing to see here. But I think what's interesting about this, like you just laid out there, was that it's not so much the number of volcanoes that we see happening right now, because like you said, it's 46. We're within the range. Well, we're at the high side of the range anyway. But it's the frequency of where they're at, and they seem to be getting stronger as more go off. Right? We saw Tonga get happen, but then it seems like the frequency of bigger volcanoes have been more frequent since over the last 3 or 4 years as we've watched this stuff take place.
Yeah, and you made a comment. If you had 10 VEI4s, was that does that equal one VEI6? It doesn't. I mean, it's not even close. The VEI6 is so dramatically more larger that you will have local effects.
Right.
VE4s and VE5s. It's like Mount St. Helens, I think, was a 5 or borderline 4 or 5 here that went off 1980 or something
81.
Like that.
Yep.
It was a wild situation, but it just had a local effect to us. It had no global impact to climate because it's just the exponential differential between one level to the other is so enormous. It's not even close. Yeah. It really needs to be. I see so many people, they send emails and texts because they know I'm on top of this kind of stuff, and they say, "Oh, there's all these fires. This is going to have a major impact." I'm like, no. It'll have a local impact. So if Papua New Guinea, they're going to have a local impact because it's right there, and they're going to have an impact, but it's not going to have a global impact other than very, very, very local at that time. And so that's what you have to really, separate the excitement over just watching a volcano and all that goes with it, and the lava flows and all that stuff, to what's actually going to impact climate. It's got to be a VEI6, period. If it's not, anyone that tells you it's going to have a major impact on climate is not giving you the correct information. I've done work and read the smartest people for decades on this topic. It's got to be VEI6. And Tonga was a VEI6, just in the opposite, aerosols of water vapor. And it is having a dramatic impact on hot weather extremes, as speculated by some of the smartest minds in the world. And even though we haven't had one of these in 1,000 years, the speculation is proving itself out to be correct. So the next, if and when we ever get another one of these, we'll know that, be on the lookout for some wild hot weather extremes, which we've clearly seen post the Tonga eruption in early 2022. So, this is this will go down in the annals of volcanism. That people can look back at Tonga and say that is what a water vapor VEI6 does to the world's climate, and it's very impactful. Just in the exact opposite effect, it's a heating effect, it's a warming effect, it's a drought effect. We still have 100-degree temperatures in northern Brazil. We've had literally averaging 100-degree temperatures for almost 2 months now. And then they're barely getting into summer. It's extraordinary. It's extraordinary what volcanic natural forces of nature, like volcanic eruptions, how much of an impact they can actually have on our climate. It's amazing. But they do. There's certain things that don't. There's certain things that do. Ocean temperatures do. Sun's activity does. Large volcanic eruptions do. I mean, those are clear drivers of big, dramatic, and extreme climate change.
Yep.
So,
all right. So you brought up in my next topic that I was going to talk to you about there. The weather forecast for Brazil is that there's some parts of Brazil that could get some much needed rain. I don't know. It's the way there's the weather information is coming through is that it's we're getting rain, but they don't really say how much and what it looks like and if it's widespread or if it's narrow. It sounds like to me it's a very narrow band that's going to get it, but it doesn't sound like it's that much. But we still have the heat to deal with, so as a growing up in Kansas where it can be 105 degrees during the day, we get a rainstorm that comes through, and it rains in the morning, and by the afternoon, all the effects of that rain is gone because it's 105 degrees outside. When you're looking at the situation in Brazil, this rain event that's coming through there, is that enough to swing the drought nature that we see there, or is it not a little too late type of a situation?
Well, look, it's never too. We're still trying to plant the crop, so I mean,
Sure.
it's not too late. It's too late in February for
Right.
for soybeans. It's too late. I mean, it's not too late. To get some beneficial rains that can help the crop because they're still trying to get it planted. The problem has been because it's been so dry and so hot. A lot of the crop that did get planted in soybeans has to be replanted, but because they haven't had any rain until, let's say, this past weekend and through this week, they've not been able to replant that, and they haven't been comfortable planting new acres because you're planting it in absolute, dry subsoil. The biggest does it just to give an example, I'm just going to be looking at a screen here. The average coverage of precipitation that this 1 week's worth of rain is going to have in North Brazil, okay? This is the average, is about 50 millimeters. An inch is 35 millimeters, okay? So we're talking about roughly an inch and a half of rain on average will have fallen over a 1 week's time frame. By the way, every day is 100 degrees plus.
Right.
We have deficits. So if you go from October 1st through the current time frame, we have deficits that are in excess, depending on exactly the area you're looking at, in excess of 10 to 15 inches. So I will lay it out as a logical person. It says if we're 10 to 15 inches deficient from October 1st to the point that the rains started to occur, and we get an inch and a half of rain over a week's time frame with 100-degree temperatures, that is not going to even cover the evaporation rate, meaning that the rate at which that rainfall is evaporating on a daily basis is fairly equal to the rain that's fallen. And so all this does, Casey, is it prevents things from deteriorating further for at least a week. It gives them a little bit of moisture maybe to try some plantings again. But the following week after this, no rain, 100 degrees plus.
Yeah.
Now remember, so what's going to happen is this is a pause, and then we deteriorate next week. In Argentina, the 1 in 100-year drought last year, half a crop, 50% down in corn production and soy production. Imagine being 50% down here, Casey. Just imagine having 50% crops in the U.S.
Right. Yeah.
That's what they had down there. That's what they had. That's how bad it was. But they had 3.5 inches of rain in early February. Still an important time to get rain that could have helped the crop. Okay, 3.5 inches in a fairly short period of time. The soybean market, I believe, at that time dropped $1.50 because of that, and it stopped. And 100 degrees, 105 degrees came back, and it didn't rain. And within 2 weeks, all the evaporation rate erased all of that, and we went on to the worst crop they've ever had in Argentina's production history. So once again, it's not so much. Look, North Brazil is like as large as like half the United States.
Right.
Okay.
Yeah.
You're not going to go through a whole growing season and not have some rainfall somewhere. It's just comical to think that the rain's falling. Well, of course it is. I mean, you're kidding me? That something's going to fall somewhere along the line.
Sure.
Come on.
Right.
So let's just. So is it a pattern change? So I mean, if it's a pattern change, I mean, if we're going to keep getting this, then that's a game changer. Okay, game changer. Why is it happening? It's happening because it's a frontal boundary rain event. What that means is that the way in South America, in North America, fronts come down and like this. In South America, they come up, right? So we have a frontal boundary. So if you look at Argentina, it's super cold down there because a cool front's coming up. So something that's called the Antarctic Oscillation Index is a measure of how wavy the jet stream is. Okay. Right now, the AAO is in positive territory. When it's in positive territory, it allows these frontal boundaries to come further north. And when they come further north, you get a little bit of rain. But then you know how fronts come. Fronts go up and they dissipate.
Yep.
It's a short-term thing. It's not what drives North Brazil weather is Amazon monsoon, period. What drives south is Atlantic flow. So, yeah, you can get a little bit of rain from a frontal boundary, but it's not a pattern change. It's going to dissipate. We're going to go back to hot and dry next week or two. So until or if and when we see the Amazon monsoon firing up moisture into the North Brazil area, where that's more of a permanent feature of repeated rain, atmospheric river conditions, this is not a major weather pattern change, and it's not that much rainfall. They have very sandy soils in Brazil, where we think everybody has soils like we have here in the United States, dark ground, black ground, and absorbs the moisture, holds it forever. They don't have that. It goes in, it goes out, and out. They need constant, steady rainfall to keep it going because it's porous. It goes in, it goes in, it goes out. So they, an inch and a half after being 10 or 15 inches deficit with 100 degrees, it's laughable that's going to do anything but hit the pause button. So obviously a lot of people are short the market and are trying to convince the market that this is a game-changing rains, and because they desperately, in my opinion, need to get their short positions in better shape than they are, at least for soybeans. That's my speculation. Why would they be saying such nonsense that they're saying? You could tell they're talking their book. That happens all the time. People talk their book all the time.
Right.
They're the wrong side of the market. They know the wrong side of the market. So they're going to say the first raise, oh my gosh, this is, this is a $1 trillion rain. Oh my God. Anyway, that's what makes the market, Casey. And that's what we love about them.
Right.
People can say whatever they wish, but the facts are that's just not a game-changing weather pattern yet. Now, if there is a game pattern change, we're not going to be oblivious to it, but this is not. So now in the South, the rainfall has been just excessive. And we're now hearing that massive replantings are now going to have to take place because the ground is underwater and it's just, they got to start over on a lot of acres down there. So when I look at that scenario, Casey, replantings in the South, replantings in the North, the rainfall, reasons, the rainfall in the South there's no indication that Atlantic flow is going to stop. I don't know. I have never seen a situation like this. And soybeans are reacting. They reacted and they sold off on, it's going to rain. It's a $1 trillion rain. Then they started rallying yesterday. I don't know, Casey, and unless I've lost my mind, somewhere along the line between here and the end of the year, the soy market needs to really get its act together and correctly price in the worst start to the Brazilian planting season I have ever seen in recorded history. And I view recorded history in South America 1950 in terms of real record recording. Never seen anything like it, quite like this. So with that in mind, I would say that farmers, producers out there who have soybeans that are left from their harvest, or looking at pricing in next year's potential harvest or protecting downside price risks, I still believe there's going to be a very good opportunity to bring more money home on the farm when this weather scenario truly plays out in the minds of the market at some point. I can't say for sure exactly when that point is. Nobody can. But the closer we get, and further we get into the growing season in December, the more the market's going to have to start putting pencil and paper together on their spreadsheets and going, this is not going to work out. And what you're going to start to see is everyone's going to start, well, it's supposed to be 165 millimetric. It's 160. It's 154. 140. They're going to keep boom, 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 boom. And once that starts and the snowball rolls, then the question is how speculative do these funds want to get, and how much of an overshoot are we going to get? I don't know. A lot of that depends on what's going on in the market at the time. Needless to say, I don't believe sub $14 soybeans are correctly ascertaining this kind of a weather scenario at this time. So that's where we're at. So
yep. It's crazy times, man. You look what's going on down there and the way things are shaping up, that you have, the North and the South are both in having crop issues for two completely different reasons. And it's a very, very unique situation. Like you said, unprecedented times where we see things going through, and kind of hit on it a little bit. And there's a lot of factors playing into that Brazilian thing. But going back to the Tonga volcano issue, if you look at the world right now and you look at where the most condensed amount of heat has come from in a lot of recorded history in a lot of areas, it was post volcano. So,
and I want to. There's been a couple of times that we had a hot, dry start.
Yeah,
not like this. All right.
Yeah, not like this.
Nothing like this. But there's been a couple of years that we've had a hot, dry start. 2015 was the last year that we had something, something like this. Soybean yields were down 10 to 12% that year. Corn yields were down 20% that year, 15 to 20% that year, depending on the region you were in. In this scenario is much, much worse. Now, obviously, the growing season isn't over yet. Okay, we have a long way to go. What I'm saying is that when we had a much better start than we had this year, albeit hot and dry, we had some pretty significant shortfalls in overall crop production in Brazil. So if we're starting off this far behind the eight ball and we have any kind of continuation of this weather pattern, like you typically do with these things, the prospects for production based upon the history of the last couple of times, which show those kinds of reductions in yields on both productions, that's the minimum expectation we would be expecting here, unless there's a dramatic change in the weather pattern. And I mean dramatic change in the weather pattern to turn it around. We're minimally looking at a repeat of what the last couple of times looked like, and this is much, much worse. I don't think people are correctly. Everybody looks at moisture, and I don't think everyone's looking at the heat. The heat is so over the top. I don't think people understand what it means to be 100 to 105 every day.
Sucks. I've been there.
Well, what I mean is, I don't think they really understand the difference between.
Oh, it's huge.
Cool and dry,
right,
and hot and dry.
Yeah,
I am a total understanding that crops can get through very minimal moisture if it's not too hot. It's proven time and time again that if you get just a little bit of rain just when you need it, even if it's not hot, the genetics we have, we can have a crop. Whereas 100 years ago, we couldn't have a crop. But not if it's 100 degrees. It's not going to happen. And I think that's somehow people are not equating how hot it is. I hear some people talk about it, but then when they say that, oh, this is a trillion of rain, save the day, I don't think it's 100 degrees all week long. I don't think they're not putting the temperature. There's something called a thermal condition index. It's the satellites. So the satellites can measure a lot of different things. They can measure vegetative health, and they can measure what's called thermal condition, which means how much stress is being applied to vegetation based upon heat. And we're at it goes back to 1979 when the satellites really started putting this information out. We're at the highest thermal condition index, meaning the greatest stress ever seen by a long shot since 1980. The vegetative health index is the worst, meaning that the vegetation is the worst it's ever looked at this time of year by a long shot. This is satellite. This is not someone's opinion. This is not someone's conjecture. Maybe the satellites aren't perfect. Maybe they make mistakes, but it's a steady data point that we can relate to past data points. And we're at the worst vegetative health and the worst thermal conditioning at this point in time, going back to 1979 by a long shot. So satellites confirming that this heat is devastating things in northern half of Brazil. And if the heat backs off and the rains come, obviously that can change things. But so long as that heat is what it is, 1.5 inches is not going to get it done. I'm sorry, but the $1 trillion rain is maybe they're measuring it in Argentine pesos or something, but it's not in U.S. dollars.
That would definitely make more sense if they were doing it in Argentine dollars.
$1 trillion Argentine pesos would maybe be like $1.25. Yeah. That makes sense to me.
Maybe it was
$1.25 rain. Maybe I'll go for that.
That might be what they mean. It just
I think that makes more sense to me. Maybe they increased crop production by $1.25. I think that definitely I could be on board and go with that.
You can live with that one. Okay,
I can live with that one. I'm all right with that. Yeah.
Awesome.
Yeah.
All right, Shawn. Good stuff as usual. Folks want to reach out to you and get more information about what you're doing over at Hackett Financial. What's the best way to do that?
Our website is Hackett, Hackett, advisors with an S.com. We have a Twitter page at Feridex, Feridex 11. Also have a LinkedIn page. We put some stuff on there from time to time that go over interviews and some things that we're looking at with climate and cycles to see if what we do with agriculture might be of value to those watching the show.
Right on. Well, Shawn, I appreciate you being on, man. I'm thankful for you coming on this podcast and talking like you do and giving me your time to do all this. So I appreciate all you've done for me here over the course of this year, man. So thank you very much.
Thank you, Casey, and thanks for the opportunity to share this kind of information. Not everyone is open to some alternative thinking, as you know, and I appreciate that ability to get this out because I think it's important information that is not being put out by many, but it's also extremely factual and important. And I think you're doing a great service to those in agriculture that watch the show. So
I think alternative information might be a slight understatement with what you put out, Shawn, because this is the only place I swear I look forward to talking to you every time, because when you come on here, there is a high likelihood that you're going to tell me something that I have never heard in my life, and I can Google it and find it, but it's like buried under so many levels of things that it's hard to find. And I commend you for your research and what you've been able to do here, man. So this is awesome having you on the show, man. I appreciate it.
It's funny. I've been speaking quite a bit this past month, as you know, probably why I got sick, I guess. And I've been talking about, this El Nino Mordecai and all, and no one's heard this. No one, not at least the people that were in the room in these various conferences, no one's heard about this. Most people thought, there's no El Nino Mordecai. What's this guy? So everyone, you do a search, it pops up.
Oh yeah.
And there's all this information, what it is.
There, yeah.
High, smart, incredibly smart doctorate people that have degrees all over the place talking about Mordecai and what it means. And they go, gee, I've never heard of this. And now I do research. There it is. I never would have known. So it's just interesting that, that stuff that's actually out there that is well known by those in, it's just interesting that something that's well known by many is not well known by many, because it's not something that is talked about on your widespread outlets of information. They just don't talk about this kind of thing, and yet it's a huge driver of our climate. And so I'm grateful for that. And now everyone that has seen me will say, I now know what a El Nino Mordecai is. And now in the future, anybody that I'm going to be looking out for this. So I get great satisfaction in that, because it makes everyone in the room better at what they do, because now they have another tool in their chest on a weather pattern that they didn't know before.
Yeah.
So.
Well, when you started talking about Emoticais the first time, I was like, this must be, I didn't know Shawn was into Brazilian Jiu-Jitsu. This is great. I'm going to learn something. But no, it's about the weather. So I've had you speak at my thing, I don't know, 2 or 3 times. And everyone walks out of there going like, I had no idea what he was talking about. And he made this stuff up. And I go, just Google it. Go Google it. And then it comes back and they're like, yep, that's right. It's there. So,
well, I always tell people, put in your computer the year without a summer. It is real.
Yep.
It happened after Mount Tamboura at the last grand solar cycle. It's not made up. It's there, and and it's factual. So as hard as it is to believe, this rodeo has happened before.
Yep.
It's just that no one's alive to tell us it's happened before.
Yep.
So we have to do our own work and have the faith and conviction of historical context, be willing to project it out into the future again. That's all.
And just to shine a little light on how actually devastating that volcanic activity was when it went off, was there were articles you can go read about the winter of 1915 and 1916, where the was the Texas Gulf, like the right around like Padre Island in that area, where there was enough ice in that on the ocean there that people could ice skate in there. So that just kind of shows you how devastating these volcanic eruptions can be when they get to that level. So, Shawn, I appreciate your research, and I look forward to talking to you again after Thanksgiving here.
Me too. Thanks, Casey. Appreciate it.
All right, have a good Thanksgiving, man. Tell your family hi for me, and we will talk into you next week.
Sounds good.
Right on. I'm Casey Seymour with Moving Iron Podcast. Check me out on Facebook, Twitter, and Instagram at Moving Iron LLC. Go to LinkedIn at Moving Iron Podcast. Check me out on Snapchat at Moving Iron Podcast, and I got TikTok now, so check me out over there on that at Moving Iron Podcast. Go to the video version of this on YouTube, which is the Moving Iron Podcast YouTube channel, and everything Moving Iron related. Check it out on movingironllc.com. And we got some announcements coming up here over the next couple of months. You'll see, and hopefully a new website coming up here before the sometime the first of the year. So with that, I'm Casey Seymour, Shawn Hackett. Let's move some iron, folks. Out.
Moving iron in the 21st century. Hard work.